Sebastien. I'm technical evangelist or developer advocate for AWS in EMEA. Coming from Belgium, usually speak French, as you might have already noticed, with a slight touch of French accent, or maybe if you were in the earlier session this morning. And you can reach out to me on Twitter, GitHub, Stack Overflow, these place where coders or builders are spending their time. Don't hesitate to share feedback, to share tweets or pictures about this conference. I love to hear your feedback or to engage the conversation after. Don't forget the quiz at the end of the day as well. After the last session, we'll have a technical quiz in each room, and we have 300 credits, AWS credits, to win for the people that are going to answer all the questions the quickest as you can. So this talk is for builders, for developers, for people that are writing code, both front-end and back-end. And congrats. Because you have just been hired. You have just been hired to a new company called Elastilodge. Elastilodge is a chain of hotels. You have been hired there to modernize their mobile application and working at the same time on their backend. So this is a company that has no mobile website. It's like a native company from last century. They have a very monolithic application with an old guard database. Maybe you know that. You've been through that already before. They have a REST API, but the data structure and the REST API is really designed for a desktop, and it's not really designed for a mobile application. So the new CEO hired a mobile agency to make a design of a mobile app, and you're in charge of helping to realize the prototype of that app and to go from a design to a working prototype, from a graphic mock to something that you can show to your stakeholders. Of course, you have to do that very quickly. In 4 weeks, you have to do that on top of your day-to-day job. Taking care of daily operation as well. So the kind of projects, why did I accept that? Maybe you recognize there, I see some smile in the audience, maybe you did that before already. That's not really a comfortable situation to be. So how can you do that with modern tools, with the cloud, with modern API? That's the subject of the rest of the talk. That's the REST API that you have, very verbose, long API that gives you details about an hotel with all the details, including the manager name, email address, all the restaurants around the hotel. So yeah, a lot of data there. And that's basically all what you have. So REST API are great. REST API are there since, what, around 20 years now, almost. Before that, we were doing something called SOAP API. Anyone has gray hair here, like me? Remember SOAP API and XML namespace and JAX RS something and JAX stuffs? I'm happy I forgot that. So companies like eBay, like Salesforce, and just a bit after, Amazon introduced REST API based on HTTP verb, get to get data, post to update data. But there is a few challenges with REST API. One of them is the verbosity. It's very chatty. In a very well-designed REST API, you retrieve one document, and then if you want to get more details, like my hotel details, if I want to get the amenities, if I want to get the price, if I want to get the restaurants, typically I'm going to make, the client is going to make a second HTTP call to get the details of the restaurants for that hotel, or to get the details of the price for that hotel. So it results of a lot of back and forth between the client and the server. You need to call first an API to get a first document, then you pass the link, and for each link you are going to make another HTTP call to the server. That's chattiness, and chattiness has a cost, not too much into bandwidth, but in terms of latency. The latency, as you know, is the time it takes from a small packet of information to leave my laptop, go to the server, being processed by the server, and to come back there. And opening a connection, an HTTPS connection, takes like 4, 5, 6 packets to be exchanged. And latency across a good network from Europe to US, it's like what, 100, 150 seconds, or milliseconds, sorry. Milliseconds. So multiply that by 2, 3 to open an HTTPS connection, and do that, multiply that by 3 or 4 for each HTTPS connection. It might be like 1 or 2 seconds waiting before to get the first result that you want to present to your customer. So Chattiness is one of them. The other problem of the REST API, it's the length of the document. You saw my example of legacy REST API. There is no way for the front-end developer to say, I just need data A and B. You call the API and you receive whatever the backend developer decides that you need to receive, even if there is a lot of data that you don't need. And that's a bandwidth problem, especially on mobile device, where sometimes bandwidth is constrained on edge network or flaky 3G networks. So how can you work around a REST API and improve the REST API? And that's why GraphQL has been introduced a few years ago, like 2-3 years ago. Anyone heard about GraphQL already? Heard? Anyone using GraphQL already? Just 2, 3, 4, a bit less. Thank you. Congrats. So GraphQL is a query language for API. That's a QL, like in SQL. There is GraphQL. For API, especially for data that are like graph database, it has been created by Facebook that has exactly that same problem. When you're reading your Facebook feed, you see all the posts and you see all the comments by all your friends and the profile of your friends. So getting that one by one through REST, it's very chatty. And GraphQL helps them to get all the data in one single shot amongst many other different things. So it's contract driven. You define what is the operation that the server can provide, and the client can call this operation. It's type safe, and oh my God, I love that. It's type safe. Try to define a type with REST. It's actually very complicated. Yes, I know there are some ways to define type in JSON, but it's not really standard. Type safe means that we can introspect an API. So we can write a tool that will look at the API, define the types, and generate client code for me. I don't need to write my low-level Plumbly or client code manually. It can be done automatically for me. It's very efficient because it allows to capture data from multiple data sources. I will show you that with example and demo quite extensively. Because of all that, it's quite easy to test and to mock. And it has also a real-time capability, a subscription capability, a push notification type of capabilities, which is very difficult to do over REST, unless you start to do some other stuff like WebSockets or other technologies. But here it's built into the API. So it has a couple of advantages. It works very easily. First, you define a type. Here I have a to-do type with an ID, a name, a description, priority, and due date. Each of these types have a type, so you know if it is an ID, a string, a date, or something like that. And then you define operation. Here I have a query operation, which is called getToDo, that returns an array of to-do. That's what you need to do as the API developer. You model your structure, your data structure, you model your operation in a strongly typed language. Then as a developer, I can prepare a query, and the query has to have a name, so getToDo, that's the one I want to do. And look at that, I specify that I want to get, oops, it's difficult to do that without looking at the screen. Just the ID, the name, and the priority there. So you're telling the server, I'm not interested by getting all the details of the to-do, I just want these 3 fields, which makes the communication much more efficient between the client and the server. So the client can request only the data they need for the user interface. And that's exactly what you're going to receive back. So you're going to receive a JSON document with the data that you ask, nothing more, nothing less. Okay, that's the basic, like in a 2-minute introduction to a GraphQL. There are 3 types of operation that you can do in a GraphQL API. One of them is queries, as the name implies. Query is to fetch data from the database, to get all your hotels, for example, for my Elastilodge example, or search for a specific hotel. You can do mutation, like the name implies, a mutation will change the data. You can modify the data, update, delete, these are mutation. And subscription, that's a new stuff that doesn't exist with REST. A client can subscribe to events happening on the server side. And you're doing that all the time. If you are using the Facebook mobile application, if a friend of you comments a post, you will see the post appearing in your mobile application immediately, or even in the web application. That's a subscription. It's because the client application or the web application is subscribing to new comments on the server side. And the server pushes that to all the clients, all selected clients in almost real time. So these are the 3 types of operation you can do. Does that mean that REST is dead and you should stop using REST API today? That's a thing from the past that eventually will fall into legacy with COBOL and mainframe? No, I'm not telling you that. I'm just telling you that for some type of application where you want to give a bit more control to the front-end developer, or where you have multiple data structure, variable data structure, unknown data structure, and the application, the client application needs to fetch a lot of data from multiple data sources, then maybe GraphQL is more adapted than REST. So I'm not telling you REST is old technology, go to a new technology because it's hype and fancy. Never do that, never replace existing code. If it works, it works. Don't break things. But sometimes for new application, for prototype, when you need to go fast or for new use case, looking at alternative is always good to open your mind to other type of technologies. Client-driven development, I think it's one of the very key values of GraphQL. So defining the API is great, and then you need something to run that API. You need a server that will actually receive these requests and send these requests. You have a couple of options. One of them is to run your own server. You create virtual machines in the cloud, in the AWS cloud, for example, and you install Apollo. Apollo, it's an Apache open source server for GraphQL. Great. But if you do that, you have to maintain that server. You need to patch the Linux. You need to patch the server. You need to ensure the server is highly available. You need to ensure the server will scale with the number of requests you are going to receive per second. And that's low-level, boring things. It will not make your app better. It will not make your application better than competitors or providing better service for your customer. This is what I call the plumbery, the low-level stuff. Everybody has to do it. It has to be there, but it doesn't bring any added value for your customer. So the alternative is to let us manage this low-level stuff so that you can focus on the API, on the data, and on the functionalities. And we have a managed service to run your GraphQL API in the cloud. It's called AWS App Sync. So App Sync, it's an AWS service that allows you to provide a GraphQL endpoint for your client application. But we do manage the plumbery, so you don't see any EC2 instance for that to run. It's like DynamoDB, it's like Amazon EC3. When is the last time you patch Amazon S3? Okay, nobody patch Amazon S3. You are not going to patch AppSync for the exact same reason. So AppSync can connect to multiple data sources, legacy REST API, or legacy, sorry, I don't want to be mean about REST, but old web API, REST API. It can connect, of course, to DynamoDB, can connect to relational database as well. It can connect to NoSQL, to DynamoDB as well. And all you have to do is to define your model. So you define your API and the operation on that model, so the API and the model. And you need to write a couple of transformer, and I will explain what is a transformer. So we do conflict detection in the cloud or in the client SDK, and it integrates with IAM for security, as we explained earlier in this track before. It integrates with a Cognito user pool to manage authentication, authorization, or it integrates with anything that speaks OpenID. So you can get your authentication token from a third-party provider, such as Twitter, Salesforce, log in with Facebook, log in with Google, and just pass that token back to AppSync to verify the access, to verify if the user is actually authorized to access that API. So AppSync, it's like a server. It's a server. It's connected to multiple data sources, Elasticsearch, DynamoDB, Lambda, relational database, REST endpoint. It integrates with Cognito for user authentication and authorization, and it provides a GraphQL endpoint for your client application to use. The only thing you need to write, it's a resolver. So in the GraphQL server world, there is this concept of resolver. A resolver is a piece of code that will transform the incoming request to send it to the backend. And then when you receive a reply from the backend, it will do the transformation from the data received from the backend to whatever is expected by the client, by the front end. So it's just a transformation of data on your way from the client to the backend and on the way back to from the backend to the client. If you are using Apache Apollo, a resolver, it's a JavaScript piece of code. So you actually need to write a bit of JavaScript, and the data transformation will be implemented as JavaScript. At AWS, we took a different approach. We are not using JavaScript for resolver. We are using templates, because all the data source that App Sync is talking to, they are accepting JSON. And whatever we receive from the client is also JSON. So we need to transform one JSON into another JSON. And whatever is returned by the backend is also JSON. And so all we need to do is to transform that JSON into a client JSON. So going from JSON to JSON, it's an overkill to use JavaScript code for that. A simple template engine can do that. And we use the Apache Velocity open source template engine to transform the JSON on the way back and from the data source. So all you need to do is write a few JSON, and most of the time our client tools are generating that for you automatically. So let's start with App Sync. I will create a very simple API. I'm going to the AWS Console. Is it big enough? If you are in the back of the room, you can read the screen? Yep, okay. If you are sitting on the side, there are still a lot of seats that are available there in the middle, so you will be more comfortably seated. If you want to move there, feel free, especially during the demo. So, here I have already three API. Let's create a new one. And you can create a sample project, and that's great to learn about GraphQL and App Sync. We have an event app, a task, like a to-do app, a chat app, a blogging app. We have the client that are written in web and sometimes in Android, on iOS for these. Everything is on GitHub. Here we'll just follow a very simple wizard. So I need to name my model like demo, and configure my model. Because it's a demo, I will keep it very easy with an ID and a title, the ID being require. And then I click create, and the name of my API will be my App Sync app. So when I create that, what it actually is doing is creating a DynamoDB, so a NoSQL database, a table to store the data. It's creating an App Sync API, configuring the data source in that API to talk to DynamoDB, and it's creating the resolver for me. So just in less than a minute, I have a fully working API that I can start to use and to test in the console. You can see the schema that has been created. Let's make that a bit bigger. You see that I have demo with an ID and a string. I have a couple of mutations, create, update, and delete. And I have a couple of queries that I can use, get demo and list demo. And if you look at the schema here on the right side, we have the resolver. So you can attach a resolver to an entity or to a field. Here, let's see the get demo resolver. It's a very, very simple template because we are mapping whatever we receive from the client and we send something else to DynamoDB. If you know DynamoDB, you know that get item is the operation, the API you need to call on DynamoDB. And we just transform the ID that we receive as an argument to a DynamoDB JSON version of that ID, the one with types in and everything, which is not easy to read. And the result is even easier because we just take whatever result we receive from DynamoDB and we transform that to plain old JSON to give back to the client. So the transformer, the resolver are super easy to write. We can test queries as well, like create demo input with hello world. Hello world is the typical way to, I can create that, and I can see that I receive as a result an ID and a title. And it has really been created for me in a database. Let me just refresh this page. I should have one more table. I have a demo table that has been just created right now, and I have my hello world here that has just been created right now as well. We can query as well. That's for later. Where am I? There. So we can also send a query. Oops, trying to see. That's my list demo that returns items and just the ID and the title. So I can execute that list demo, and I will receive list demo with items, which is an array and this. And of course, if I create one more, so let's create hello world, hello Kyiv, and to create demo, and then list demo, I will receive now the two. So I have hello Kyiv and hello world. So starting with App Sync and starting with a GraphQL database is actually super easy. It takes less than a minute, and you can directly start to experiment your queries and to prototype your queries in the console. You do not need to write a single line of code to do that. So let's go back to ElastiLaunch. For those of you that were here at the beginning, remember you have been hired to a new hotel chain, and you need to write a prototype of their new mobile application. This is the design that you receive from the design agency. They designed something quite fancy with an image, a map of the hotel, a button to check the availability. And your job is, okay, I have my REST API legacy, I have that new design. How can I glue these two things together? So how can I connect that application to an API? And we are going to use GraphQL to do that. We are going to build a facade with GraphQL to connect to the older REST API. So remember the REST API, it's that very long JSON document with tons of data that you don't need. Actually, most of the data that we need for that screen are available in the REST API. That's good news. But the REST API has also a lot of data that we don't need. So let's create a GraphQL schema which is just suited for that iOS application or Android application, that mobile application. So that will be my schema. I have an hotel ID, name, image, location, phone number, address, maybe other. And I will define just in this phase one only two operations, two read-only operation, two queries, one to get the list of all the hotels and one to get a specific hotel by ID. I also need to write my two resolver. The first resolver is to go from the client application to the backend, and as you see, it's a REST backend, so I need to specify the HTTP verb and the path, like hotels / the ID of the hotels, and maybe massage a bit the HTTP headers, like saying it's an application JSON MIME type, for example. On the return side, I need to write another resolver that will take the DynamoDB from the JSON from DynamoDB and transform that. And we are going to make something super easy here. If the status code is 200, it's just a pass-through. If it is not 200, then we return an error to the client. So these two resolver, it's only a few lines of code, very easy to write. From the client developer point of view, all you need to do is to define the operation that you want to send to AppSync. I want the get hotel, and I specify hotel ID, blah, blah, 3, for example. And you just list the fields that you want to receive. So if you don't need more than that, you just need to list name, location, image, phone number, address, blah, blah. And that's the JSON that you're going to receive. So how do you integrate that in your client application? You can do the low-level coding by yourself, because an app sync call, a GraphQL call, it's mostly like a REST call. You need an endpoint, so an address, JSON, and a couple of headers for the authentication. So you can develop the low-level HTTPS call by yourself. But of course, we do provide an SDK for you, so you have higher-level functions that you can call from within your mobile project or your web application projects. And we do support iOS, we do support Android, we do support Java and Kotlin, we do support Objective-C and Swift. So this is a Swift example on iOS. First thing to do is to create an AppSync client. AppSync client is an object provided by the SDK, giving some configuration, basically which account, what API inside the account, a couple of other details about caching, and you're gone. So I didn't show the config. It's way too long, like 4 or 5 lines of code. Didn't fit on one slide at this size. So the only thing you need to remember is create an AppSync client. And then you call fetch on that client, and you pass an object which represent your query. So in this example, I have a get hotel query object that I'm passing to the AppSync client fetch type of API call. And that object, get hotel query, is generated automatically. Remember, I told you that GraphQL clients have, GraphQL is strongly typed. So we can have tools that introspect an API and generate code for you automatically. We have a tool doing that. It's called Amplify, and I'm going to talk about Amplify in the next session next door, just after this one. That's a shameless plug to the other session after if you want to get more details about Amplify. So let's see that in real life. I have my App Sync console here, and as you saw already, there are a couple of API there, including no, that's not that one. That's the Elastilog API. So I can click there. I can see the schema that has been created for address, for hotels, the type of mutation of queries, list hotel, get hotel. The data source, right now there is only one which is required. It's the HTTP one. So I define my data source and I give the endpoint of my REST API. And of course, a couple of queries, like I can query for a specific hotel. And we can try that get query, and we see that we receive data there. So we know that the API is working. We know that the backend is working. Now, how to integrate that into a client application? So let's switch to my phase 1 code. That's Xcode. That's the iOS development tool in Swift. I'm creating my App Sync client. I told you it's a bit too long to fit on a slide. Then that's the line that you saw on the slide to create the App Sync client. And that's the fetch line where you fetch the data for a specific hotel. So in real life, there is a bit more code than on the slide because you need to plan for errors, of course. If you were at my first session this morning, you should implement retry, backoff, exponential retry, jitter, and all this stuff as well, which I didn't do here because it's a very simple demo. So the good news of that is that it should work. So if we run that application there, we have the mockup that has been created by the design agency, fetching names asynchronously. I don't know if you saw that, but when it appears, it's a placeholder first, and then it fetches the data from the API, and it changes the data, and it displays the data. You have the address, the category. I don't have a fancy image there because I'm not a graphical user interface designer, but it's just a placeholder. And voila, so in less than 20 lines of code on the client side and a very simple API, we can integrate existing REST API, repurpose them, refit them into mobile application. And I'm using mobile application here just for the fun of it, but it works also with web application, of course. So it might be a web, like Angular, React application, Android on mobile, or iOS on mobile. So what about in our prototype, how to integrate reservation systems? What data is required to actually ask for a reservation? We need to authenticate the user. I will not talk too much about user authentication and authorization. I think I can make a full session on authentication and authorization in App Sync. So an easy way to add reservation, to tap into an existing system, is to first go to DynamoDB. So you have a very quick way to save the data, and then have an asynchronous process that will take the data out of DynamoDB, call to your legacy reservation system, wait for the reservation to be confirmed, and send a notification back to the client. So the way to do that would be to add a type in my API, like a reservation type with a confirmation ID, the reference of the hotel, the reference of the guest, the start date, the end date, and the rate, and add a couple of queries and mutation. In the query, you want to be able to list all the reservation for a customer, and you want also to be able to create and to delete a reservation. So that's all you need to do on the App Sync side. On the App Sync, you create a new data type, and you define the operation on this data type. Of course, you need resolver as well. This resolver is not very complicated. It has 2 or 3 lines more than the previous one. But the resolver to go from the client to DynamoDB, it's quite easy because you are going to make a query operation on DynamoDB. So a query operation, it's one that can scan all the entries for one given customer, for example, when you have a composite key with primary key, secondary key. If your customer ID is the primary key, the query operation will check for all the reservation for that specific customer. And in that case, we want only the one in the future. So we want only the start date of the reservation to be to be after today. So we define today, that's the first line there, and then we write an expression like guest ID equal GID and start date bigger than start date, and then you define what is GID and start date. GID is the identity of the current customer. The identity comes from the authentication, from the JWT token, from the access token that you receive through authentication, and the start date is just today. The result is even easier. You take whatever DynamoDB is giving you back and you pass that to the client. From the client developer point of view, the only thing you need to do is to create a new query. The query exists, it's guest reservation, and you say, I want to call guest reservation, and these are the fields I want to get. So look at the hotel field, for example. It doesn't return the whole set of data for an hotel, but you specify within that entity what are the subfields that you want, like hotel ID, name, image, and phone number, and nothing more than that. And then the start date and the end date. So the way it will work, the client will send that JSON over HTTPS to App Sync. App Sync, through the resolver and the data source, will write into DynamoDB. And then, of course, you need to do something which is outside of the scope of this talk and this demo, is to implement with your legacy system. So one very nice way to get the data out of DynamoDB is to use a Lambda function as a trigger. A Lambda function is a piece of code that can execute in the cloud for you, and you hook your Lambda function to events that are happening inside your AWS infrastructure. So a Lambda function can be started when an object is dropped on Amazon S3, for example. Or a Lambda function can be triggered when something changes in a DynamoDB database. It's the same old concept of trigger. Maybe you worked with relational database last century. Remember PLSQL, things like that? No, I'm joking. I know you are still working today with a relational database. But yes, it's a trigger, except that it's not running inside the database. It's running in the cloud. So Lambda function can be a trigger for a DynamoDB database. And assuming that you have a legacy system that has an API, that Lambda function can call your legacy system to make the booking, for example, and process the payment and all the complexity related to booking an hotel room. Whatever happens, sometimes, eventually, the system will return and you will have a confirmation ID. So how do you bring back that confirmation ID to the mobile application? And this is where subscription is a really nice fit for that type of architecture, because it's totally asynchronous, so you don't know how long the reservation will take. It might take a few minutes if you need to process a payment, for example. So you would like the client to also subscribe to change in the model on the server side. So the client app, the mobile application, will send a mutation, a GraphQL mutation, to say, hey, I want to create a reservation. And at the same time, it will register to a subscription. Which subscription? A create reservation event. And of course, I don't want to receive all the events of all customers. I just want to receive the events of my customer ID. So you say create reservation event for guest ID 1, which is my guest ID, and I just want to receive the confirmation number. So it looks like a bit magical, because from a client developer point of view, you just call the App Sync client subscribe, that's the second line there, and you pass a function, a handler, that will be called whenever something happens on the server side, and that's it. And when something happens on the server side, that handler will be called. You first need to check if there is no error. If there is no error, you fetch the data, you update your local cache, and you update your graphical user interface, and voila, you're done. You have your new confirmation that arrived there. Without GraphQL, implementing that means you need to open a WebSocket, have a WebSocket server, make long poll, or whatever technologies you want to keep the connections between the client and the server. Under the scene, our SDK is using MQTT, so what we are really doing, what this subscribe call is doing, it's starting an MQTT pub sub with the server. But you don't have to manage the MQTT broker, that's part of the AppSync service on the server. You don't need to manage the MQTT client, that's part of the SDK on the client. All you need to do is really this. So let's try to see if it works. It's not only slideware, it's really real live type of things. And let's go to my phase 2 application and start there. So the change here is that I implement the subscription exactly as it is on the slide. And actually, the resolution is not large enough to let me. Can I have? I have a small technical problem here, is that the screen is too small to reach the bottom of... OK, let me switch to something. Just a second, just to click on the button there. Hop, and come back here. So I click on the tab on the bottom part of the interface to go to the reservation part. And you see I have no reservation right now. In my API, I have queries to create reservation. I have get hotel, I have get the reservation, create reservation, and test subscription. So if I'm doing a get reservation, I have a 0 reservation right now. And if I'm going to my Elastilodge DynamoDB table, there is no item here. It's an empty database. So let's create a reservation with the App Sync console. And because the mobile application is subscribed to the create reservation event, as soon as the reservation is made, it should update automatically and show you that actually there was an update there. So I don't have a lot of space here. Let's close this. It will be a bit bigger. Oops. So that's get hotel, get reservation, create reservation. So I will create a reservation for hotel ID 1, guest ID 1. It's important to have the correct guest ID because the iOS app is listening only on guest ID 1. And it will be for 3 days in the future between 1st and 3rd of July. So let's call that create reservation. And you see that the iOS received a message and update the GUI automatically. I can do that with another hotel, for example. So I'm just changing here the hotel name. Let's change the month, 8 and 8. And let's create another reservation. And I should receive another one. And you see that the months have been updated. It's August, and the other one is July. And the name of the hotels are different. So it's only a few lines of code, like 10 lines of code, to actually go from one to from a mutation to a subscription. Before to conclude, one of the last cool things of GraphQL is that you can have field resolution not only at the operation level, but at the field level. It means that in the same query that brings back data, you can have multiple data sources. Like my hotel details are coming from my legacy REST API, but I would like to have the rate of the hotel coming from another systems, because there is another team at Elastilodge working on machine learning stuff to do adaptive pricing and choose a price depending on the season and your previous experience and stuff like that. And they have a separate REST API to do that. So what you can do with GraphQL and with App Sync is instead of attaching the resolver at the operation level, you attach, in addition of that, a resolver at the field level. It means that all the fields are going to come back from one data source, like the hotel details, but that specific field, here the rate part at the bottom of the screen, will come from another data source. And of course, you need to define that field in your GraphQL type, what is a rate, and you need to write a resolver with a different data source, a different HTTPS endpoint, maybe a different REST type of API. For the query, there is not so much to change. You just include the rate on the query, and you will receive the rate on the response. But there is nothing more to do, because it's the same JSON, almost the same JSON that you send to the same endpoint. It's just the endpoint will return you with more data coming from different data sources. Most of the work there is on the graphical user interface, because then you need to put that value at the right place on the graphical user interface. I have only 10 minutes left, so I'm not sure I will show you very, very quickly this. But the idea is, inside your schema, let's make this a bit bigger, you have all the resolver here on the left side, address, hotel, and so far I show you the resolver attached to the operation, like queries. But you can have also the resolver attached to a field. So here I have the hotel data, and with all the fields for an hotel, like the name, the location. And for the rate, there is a specific resolver for that field. And that's the resolver you saw on the slide going to fetch the rates. And that's how you can combine multiple data sources for one single data type, which is extremely, extremely powerful. So, what we just did, we started with a legacy REST API and a graphical mock-up of a new mobile application. And we create a facade with GraphQL that is able to talk to multiple data sources, DynamoDB, the legacy REST API, which is also able to subscribe for events and to do dynamic push, dynamic updates of the graphical user interface. We were able to evolve that API, like add the rating API very easily by just adding a resolver on one specific field and adding additional data source. And all of that without coding on the server side. I did code a lot on the client side. There is no magic there. But on the server side, it was just a few velocity templates, just a few JSON templates to go from one JSON to the other. To help you to do that, we have a tool called Amplify. I already mentioned it. I'm just calling it again. I will talk about Amplify in 15 minutes in the other room. So if you want to see more about Amplify, go in the other room. I will show you how to create a web application starting from scratch and adding an API, adding user authentication, adding search capabilities. It will be based on GraphQL as well, but Amplify generates most of the code for me, so I don't need to type a lot of code on the client side. So a quote from the Netflix blog, I'll let you read that. Yeah, there is something to pay attention with when you use GraphQL. Don't give too much power to the front-end developer. I love you if you're a front-end developer. I'm also a front-end developer sometimes. I'm also a back-end developer, so I know that I cannot do anything I want with the back-end, especially that, like creating multiple data sources recursively. If you give total freedom to your front-end developer, they will kill your systems in terms of performance. I mean, really. So one of the things to pay attention is the cost of the queries on the back-end. Maybe educate the front-end developer, or at least works with them to ensure they are not doing any crazy stuff. And the other things, I mentioned it already, and I will say it again, authorization and authentication. If you follow the example from Amplify and from the Aws Sync console, most of the authentication and authorization is implemented inside the resolver, which is great to get started, great to learn, great to prototype, but please don't do that into production, because you will have tons of resolver, and you're basically replicating the authentication authorization logic in the resolver. So you should have a centralized place, like a Lambda function, to implement your authentication logic. One of the good ways to do that is to use nested queries. So typically, if you want to authorize access based on the identity of the person, you're going to have two different tables, one with the data and one with the authorization. And if you want to say that Nadia can only access to the item 1 and Shaggy to item 2. Basically, you want to say, if the owner is the current user, then I return the content, otherwise it's unauthorized. So one way to do that with GraphQL is to wrap your data access into an authentication check, into a verification check. So look at the query here. The query will return, the get data query will return OCheck data. And OCheck data will allow you to run a first resolver going to the first table, and only that, after that, include the data that you want. So if I want to make it graphically, the OCheck data will check that table, and then you filter the result of that query based on the result of that table. Seems maybe a bit complicated like that, but it's not very complicated to implement. There is a very nice blog post from one of my colleagues in the product team that explains how to do that. The slides will be available on Twitter in a few minutes, so in a few minutes you will see the slides available there. Otherwise, you just scan the QR code and you will reach the blog of my colleague explaining you that authentication with multiple data sources. All the code of the iOS application, if you're a mobile application developer, is available on my GitHub, github.com/sebsto, and you have the 3 different versions, phase 1, phase 2, phase 3, so you can see how it works and how it has been implemented as well. If you are interested about GraphQL, I strongly suggest you to read a lot about it, because the best practice, it's new. It has 2-3 years old, so the best practice are slowly starting to emerge now. There is a couple of very good blog posts and 2 very good podcasts, one of them being run by one of our colleagues in the App Sync team in Seattle. It's GraphQL Radio and GraphQL Patterns. They are easy to find on any podcasting. And they have guests like people from Facebook, from Netflix, explaining how they are using GraphQL at a really large scale in real life. So that's a very good source of inspiration if you're serious about GraphQL. And that's it. Enjoy the slides on Twitter. Thank you for being here. Do we have the time to take any questions? What time is it? 5 minutes, so I can take a few questions. The microphone is there. And otherwise, happy to talk one-to-one after this session or after the next.
Thanks for the talk. So you mentioned easy testing. So are there any ways to test resolvers in velocity templates except for using the console? Like some unit test or something, so we can verify that template is valid and it will execute correctly without deploying it to AWS?
That's a good question. I would love to. Maybe there is. I don't know. I would need to Google that. If I find something, give me your email address. I will send that to you. No, I don't know any.
Thank you.
Yep.
Hello. In your mobile application, you used Amazon SDK in order to get call to your GraphQL API. Is it possible to get your GraphQL API via HTTP or something like that?
Yes.
Do I need all the time AWS client?
So that's a good question as well, thank you. So no, you don't need to use the AWS SDK, so you can avoid that dependencies in your mobile application. You can make regular low-level HTTPS call, just passing the JSON of the GraphQL and receiving the JSON. However, the SDK does provide a couple of facilities for you. One of them is authentication. If you don't use the SDK, you will need to manage the authentication yourself. So compute the HTTP authorization header for yourself, doing a bit of crypto with AWS v4 signature, and so it's a lot of code to write. And the second thing that we are doing for you in the SDK is caching. I didn't talk about that here, but we have an extensive cache that allows mobile client to continue to operate even if the network is down. And we have some synchronization logic when the network connection goes back to synchronize the content of the cache with the remote server. So if you don't use our SDK, you need to implement something similar on your sites, which is also a lot of work. So short answer, no, you are not obliged. Long answer, it makes your life a bit easier. Yep. If it is a question about how to test the cache.
No, not really. So you also showcase nested resolvers, and it's okay when we have, let's say, not a multi-tenant application, but multi-user. Mm-hmm. What about multi-tenant applications where you have dynamic roles, so one user can belong to multiple roles that belong to multiple tenants? So is there any way we can do a resolver that will dynamically fetch, let's say, ownership information?
Yeah. Yeah, so in real-life use case, you can have much more complicated case than that. And the idea is, instead of implementing any logic in the resolver, is to implement the logic in a Lambda function, for example. So you can, in a Lambda function, you can express all the complexity that you want. You can call other systems, analyze the detail of the access token, verify the scope, for example. This is how I would do it. It's to try to keep the resolver as light as possible, just delegate to code where you can have a central unit, robust, correctly tested unit piece of code where you implement all the authorization logic there and then return the result over there.
Cool, got it. Thank you.
And Lambda is a great choice to do that. So, thank you very much for your interest and the question and the feedback. Really appreciate that. I hope you have been inspired a bit. You're going to test the GraphQL or App Sync tomorrow at work or over the weekend maximum, not after that. And enjoy the rest of the conference.